There is a place on this planet where the wind never stops and the sun sets for 6 months at a time. A place where the ice is so thick, so ancient, and so still that it holds within it a record of almost everything that has ever happened to this world. Scientists have drilled into it for decades. Satellites have scanned it from orbit. And still, with all of that, Antarctica keeps giving back answers that none of us were ready for. This is not a story about cold temperatures or penguins. This is a story about what lies beneath the ice, beneath the surface of a continent that most people assume is little more than a frozen wasteland at the bottom of the world. Because what researchers have been finding, slowly, methodically, and sometimes with genuine disbelief, is that Antarctica is not empty. It never was. And the picture it is forcing us to revise is not small. It touches geology, climate science, oceanography, and in some cases the very timeline of human understanding of this planet. To understand why any of this matters, it helps to begin with what Antarctica actually is beneath all that ice. The continent sitting at the South Pole is roughly the size of the United States and Mexico combined. It holds approximately 90% of all the fresh water on Earth in frozen form. The ice sheet covering it averages nearly 2 kilometers in thickness, and in some places it stretches down 4 kilometers or more before reaching solid rock. That rock, in many areas, has not been touched by sunlight or air for millions of years. For most of human history, this continent was not even known to exist. Ancient Greek philosophers theorized there must be a southern landmass to balance the continents of the north, but they had no way to reach it. The coastline of Antarctica was not officially sighted until the early 19th century, and the interior was not meaningfully explored until the 20th. By the time nations began establishing permanent research stations on the ice in the 1950s, the continent had already been isolated from the rest of the world for tens of millions of years, or so everyone assumed. The first major revision to that story began with sound. Seismologists studying the interior of Antarctica began detecting unusual patterns in how seismic waves traveled beneath the ice. When an earthquake occurs anywhere on Earth, the waves it sends outward pass through layers of rock and sediment at different speeds depending on the density and composition of those materials. Scientists use those wave signatures to build detailed pictures of what lies underground in the same way a doctor uses sound waves to image what lies beneath human skin. And when researchers began applying that technique systematically to Antarctica, the picture that came back was not what anyone had been expecting. Beneath the East Antarctic ice sheet, in a region called Wilkes Land, seismic surveys revealed a structure so large and so geometrically unusual that it took years of follow-up research before scientists could confidently describe what they were looking at. The structure measured roughly 500 kilometers across. Its edges curved inward in a pattern consistent with a single catastrophic event. The rock beneath it showed signs of being compressed, fractured, and melted by an enormous release of energy. The leading explanation, and it remains the dominant one in the scientific literature today, is that this is a crater, an impact crater, one of the largest ever identified on Earth. To put that scale in perspective, the most famous impact crater in planetary history is the one buried beneath the Yucatan Peninsula in Mexico. That crater, known as Chicxulub, measures roughly 150 kilometers across. It was formed approximately 66 million years ago when an asteroid struck the Earth with enough force to trigger a mass extinction event that ended the age of dinosaurs and fundamentally reset the trajectory of life on this planet. The structure found in Wilkes Land, if confirmed as an impact crater, would be more than 3 times that diameter. The timing, if estimates are correct, points to roughly 250 million years ago. That date is not arbitrary. It coincides almost precisely with what geologists call the Permian-Triassic extinction event, the greatest mass extinction in the history of complex life on Earth. During that event, an estimated 90 to 96% of all marine species and roughly 70% of all land-based vertebrate species disappeared from the fossil record within what, in geological terms, was an extraordinarily short window of time. Scientists have long debated what triggered it. Volcanic eruptions in Siberia are the leading explanation, and they certainly played a role. But some researchers have raised the possibility that an extraterrestrial impact may have contributed to or even triggered the cascade of events that led to that catastrophe. The Wilkes Land structure has never been fully excavated or confirmed through drilling, and many scientists are careful to note that the interpretation remains debated. The ice makes direct investigation enormously difficult, but the anomaly is real. The data is real. And the question it raises is one the scientific community is still actively working to answer. That is one layer of what lies beneath Antarctica. There are others, and some of them are stranger still. In the late 1970s, scientists using ice-penetrating radar aboard aircraft began noticing something unexpected in the data coming back from a region of East Antarctica near a Soviet research station called Vostok. The radar signals were detecting what appeared to be a body of liquid water far below the surface of the ice. The team was initially cautious. Liquid water below 4 kilometers of solid ice in one of the coldest places on the surface of the planet seemed counterintuitive. But the physics, when examined more carefully, made sense. The ice itself, in layers that thick, generates enormous pressure on the rock below it. That pressure, combined with heat rising from the Earth's interior, can be enough to melt the base of an ice sheet and trap water beneath it in a sealed, insulated pocket that has no access to the atmosphere above or the ocean around it. What they had found was Lake Vostok, and as the dimensions of it became clearer over subsequent decades of radar survey and seismic analysis, the scale of the discovery became harder to contain in ordinary language. Lake Vostok is approximately 250 kilometers long and 50 kilometers wide. It sits beneath approximately 4 kilometers of ice. Its water column reaches depths of over 900 meters in places, and by the best estimates available, that water has been isolated from the surface of the Earth for somewhere between 15 and 25 million years. Isolation is what makes it scientifically significant. Lake Vostok exists in total darkness, under enormous pressure, sealed from sunlight, from atmospheric oxygen exchange, and from any biological contact with the broader living world above it. And yet, when Russian scientists finally drilled to within meters of the lake's surface and recovered refrozen water that had risen naturally into the borehole, the analysis revealed something that no conventional biological framework had fully anticipated. They found microbial life, DNA sequences belonging to organisms that had no clear match in existing databases, alongside others that resembled known bacterial families. The scientific community responded carefully, noting that contamination during drilling remained a methodological concern. Subsequent analyses have continued to find evidence of biological presence, though the complete picture of what lives in Lake Vostok remains an open question. The reason that matters extends well beyond Antarctica. Lake Vostok shares critical environmental similarities with oceans confirmed or suspected to exist beneath the ice of Europa, one of Jupiter's moons, and Enceladus, one of Saturn's. If microbial life can persist for tens of millions of years in pressurized, lightless, chemically sealed conditions, then the range of environments elsewhere in the solar system where life might survive becomes considerably wider. Antarctica is not only revising what we know about Earth, it is expanding how we think about life itself. The ice sheet, independent of what lies beneath it, is its own form of archive. When snow falls on Antarctica, it compresses under subsequent layers and transforms into ice, sealing air bubbles that become atmospheric time capsules. By drilling down through those layers and extracting long cylinders of ice, scientists recover samples of the atmosphere stretching back 800,000 years. What those cores reveal about the relationship between greenhouse gas concentrations and global temperature over that span is one of the most consequential data sets in Earth science. The correlation is not ambiguous. It is one of the clearest and most consistently replicated signals in any long-term planetary record. Every meter of Antarctic ice is a chapter. Every core is a book. The rock beneath that ice tells a story older still. Before Antarctica became what it is today, it was part of Gondwana, a supercontinent that encompassed what would eventually become South America, Africa, India, Australia, and Antarctica, all joined into a single landmass positioned far from the poles. At that time, the land now buried under kilometers of ice-supported forests, rivers, and complex ecosystems. Paleontologists have recovered plant fossils from Antarctic rock, including remains of Glossopteris, a broad-leaved, seed-bearing tree that grew across Gondwana during the Permian period. Those fossils were found within kilometers of the South Pole itself, recovered by the geologist Edward Wilson during the Terra Nova expedition of 1912. They are geological proof that this continent was once something almost unrecognizable. Gondwana began breaking apart approximately 180 million years ago, driven by convection currents in the mantle below. As continental plates separated over tens of millions of years, Antarctica drifted toward its current polar position. Then, roughly 30 to 34 million years ago, the final separation between Antarctica and South America opened the Drake Passage, allowing the Antarctic circumpolar current to establish itself, the most powerful ocean current on Earth. That current wrapped the continent in a thermal barrier, cutting it off from warmer waters and triggering dramatic and irreversible cooling. The forests disappeared. The rivers froze. The ice sheet that now covers nearly the entire continent began to form, and it has not retreated since. Beneath that ice, the shape of the hidden continent has been revealed in remarkable detail through international radar survey programs. What those surveys found was not a flat, featureless plain. There are mountain ranges buried beneath the East Antarctic ice sheet that rival the Alps in scale. There is a canyon beneath the Denman Glacier, reaching approximately 3.5 kilometers below sea level, which would make it the deepest land canyon on the surface of the Earth. And there is an entire mountain range called the Gamburtsev Mountains, peaks reaching 3,000 meters, completely buried and never seen by human eyes, sitting in the interior of one of the most geologically stable pieces of crust on the planet, with no fully accepted explanation for how they formed or why they remain so well preserved. Scientists believe they may represent one of the oldest mountain ranges on Earth, still retaining something close to their original form, protected for hundreds of millions of years by the very ice that hides them. There is another dimension to this story that sits at the boundary between documented history and unresolved questions. In 1513, an Ottoman admiral named Piri Reis assembled a world map on gazelle hide, drawing from source maps he claimed included much earlier cartographic knowledge. That map includes a depiction of a southern landmass that some researchers have argued corresponds in certain features to the Antarctic coastline as it would appear without its ice cover. Most historians of cartography consider the similarities coincidental or the result of interpretive projection, and the scientific consensus does not support the claim that accurate knowledge of an ice-free Antarctica existed in any historical civilization. But the map is a genuine artifact, and the question it raises about how much geographic knowledge may have been lost during the transitions of ancient civilizations remains a legitimate historical one, even where the specific claim remains unverified. What is not contested is that during the last glacial maximum, roughly 20,000 years ago, sea levels were approximately 120 meters lower than today. Coastlines now submerged were then dry land. If ancient peoples occupied those coastal regions, much of the physical record of their presence would have been buried beneath rising seas as glacial melting accelerated between 15,000 and 7,000 years ago. That does not confirm any specific historical claim, but it frames an important truth about how incomplete our picture of ancient human activity still is, and how much may remain to be recovered from places we have barely begun to reach. The research being done in Antarctica today is among the most technically demanding scientific work on Earth. International teams operate year-round in conditions of near-total isolation. They drill ice cores with precision instruments, lower sensors into borehole water searching for life, fly radar-equipped aircraft across thousands of kilometers of ice, and deploy seismograph networks to listen to the rock below. The data they produce feeds into climate models, geological reconstructions, biological databases, and frameworks that extend the question of life outward from Earth to the broader solar system. What Antarctica is ultimately changing is not just our history in the narrow sense. It is changing our conception of the depth of that history, of how many times this planet has been fundamentally different from what it is today, of the capacity of life to persist where no surface level assessment would predict it, and of the scale of what remains to be discovered in the places we have barely begun to reach. The ice will give up more. It always does. And each time it does, the story gets longer. If this video changed how you see Antarctica, hit the like button and subscribe. We cover the mysteries this planet has been hiding for millions of years, and there is a lot more coming. And tell us in the comments what surprised you most. We read every single one.